Hello, let's continue with our section called Database Collection in Agriculture. And now we're going to talk about a very important topic, which is how to capture soil information. And which databases do we have available right now for that purpose? The database that we've used in the research group, and that's open source, and that many people, many researchers, technicians have used, is called SoilGrids. This comes from the World Soil Information, also known as WOSIS, and it captures the physical properties of soil like organic carbon, total carbon, carbonates, nitrogen, phosphorus, the soil pH, the capacity of cationic exchange probability, and electroconductivity, and also physical properties like silt, clay, and sand. That classification is the original from the FAO and the USDA, and this database is composed by more than 100,000 profiles and more than 173 countries. So it's equal to more than 5.8 million of registries. So it's a very robust database. It's very important. And it's used for many objectives in data mining and specific objectives in agriculture. So let's see how we can download this information. The first thing that we are going to do is go to the internet page, their webpage. It's called soilgrids.org. O-R-G. This is a world map that references the whole world, and there are different ways to see the map. In the upper right part, there are different options on how we want to see the details of the map. Like, for example, we have the terrain, also an aerial perspective, where we can see each one of the different layers. And in this case, we are going to choose the download option. That's in the left part. And we are going to use SoilGrid, but we can also download WOSIS, W-O-S-I-S, and we can choose the layer that we want. But for this exercise, for the demonstration of this video, we are going to focus only in SoilGrids. But you know that you can also use more layers if you prefer. And you can also see more details about this page if you want. In the meantime, we are focusing on how to download the information. So let's go to layer. And let's see the carbon density, organic carbon density. So once we choose the layer, we can also choose the depth. In this case, 0.5, the value, that will be the mean or the average, and also the point. Remember the resolution, it would be 200 times 200 kilometers. It's a very large area. So right now I'm in Mexico, and I can also say I want to download information from Mexico. So I press download, and it gives us the parameters for longitude and latitude. So we download the layer. It's a very fast download. Then we can go to the download page, and we are going to look for the file. So once you have the file in your working space, we are going to choose it and read it. So I'm going to copy it here. These are large files sometimes. For example, the one that I downloaded is already ready. And let's download it by using R. So let's go to R. And once we are in R, we are going to create a new workspace. We are going to save it. And we are going to work on it. So let's write SoilGrid and save it. So the first library that we're going to create, we are going to name it RGDA 1, and we download it. Always remember to put your name and the date. So once the library is downloaded, we're going to look for the raster. In this case, it's called out1. And we decided we're going to use a useful option that's called raster. So it tells us that the file does not exist, and that's because we have a problem with the workspace. That's a very common error. So let's see how we can solve that issue. We can go to sessions, and there we can change our working session. Let's go to Mexico. So by doing this, I've already solved the problem. So we write datos or data, and then we run it. There's no problem here. And basically that function or this library is very useful. It's very fast. So let's say that we download the data and we want to see the graphs. Let's see how the data looks like. First of all, you see that this is a raster. You see the dimensions, the values, the name, where it's located, the projections, and also the resolution. So now if we want to see how the data looks like, or how they look like graphically, this is how the layer that we downloaded looks like. Now if we want to see the points, or even better yet, if we want to see a data frame, we can see how our data frame looks like here. Head, points, and this is the data frame. And you can do this procedure with any layer that you want. You can see the TIFF file that we downloaded, and you can follow the procedure. That's all for this.